Hello, my name is Mark Satkowski and I'm from the Interactive Media Lab Dresden at the Technische Universität Dresden in Germany. I'm going to present the joint work of Raimund Dachselt and me about investigating the impact of real-world environments on the perception of 2D visualizations in augmented reality. With the technological advancements of augmented reality devices, it becomes easier to use such devices in a manifold of different use cases and scenarios. In most more traditional system setups, we rely on a homogeneous and clean background to work with all sorts of data. However, this is not always possible in AR, since it allows overlaying information on top of the real world. Therefore, each real-world environment becomes part of the AR user interface and influences how virtual content is perceived. To better understand if and how the real-world background can influence users by analyzing information visualizations in AR, we conducted 2 user studies in a real-world experimental production plant of our university. In this environment, we created 4 background configurations consisting of different available machines. To create those configurations, we relied on the feature congestion value, which measures the visual clutter of an image, as well as our own human judgment based on characteristics like motion or uniformity. To summarize, BG1 shows a white canvas and was our baseline. BG2 contained an area with high clutter due to cables. BG3 shows moving green water and slightly angled pipes equipped with LED stripes. And BG4 consists of 3 different horizontal areas that are each quite uniform. In both of our studies, we showed the participants line shots in front of those backgrounds. Further, they had to solve question blocks, which consist of 3 to 4 different tasks. In general, we recorded the measured as well as the perceived performance of each participant. Our first study had a between-subject design, based on the first 3 backgrounds. Our second independent variable was the visual complexity of the line shots, modeled by the number of shown data points. A total of 18 participants, 6 per background, had to solve 75 tasks each. As we analyzed our data, we couldn't find any significant effects of the background on the task performance for either the given answers or the task completion time. However, the perceived demand was influenced by the 3 backgrounds the participants had to work on. In general, BG3 was perceived as the most demanding background to work on, while the participants performed the fastest on it. One explanation could be that the background was decoupled from the visualization analysis task, and therefore only served as a visual distraction. Following those surprising results and this possible explanation, we conducted a second study. In this, we used the last 2 background configurations in a recent subject design. A second independent variable, a secondary observation task, was introduced which connects the real-world environment closer to the main visualization analysis task in AR. For this, the participants had to solve a secondary task, where they had to recognize a green number on one of 3 additional placed screens in the background. 16 participants solved 96 tasks each. This time, we could find a significant influence of the background on the task completion time, but not on the answers themselves. Additionally, the secondary observation task also showed no significant influence. Further, the perceived influence ratings also revealed no significant difference. However, 13 out of the 16 participants stated that BG3 was more difficult to work on. This is also supported by other comments the participants gave us. In conclusion, we found that the background has only a marginal influence on the perception of visualizations in AR. Visual clutter alone is not enough to define how great the influence of a real-world environment is, and that the overall user experience differs from the actual performance and has to be your focus while designing AR systems. Within this talk, it was only possible to show a small fraction of our study design and findings. For a more in-depth analysis, as well as our hypothesis and more result visualizations, please refer to our paper. Please visit our project page at imld.de/ar-vis-perception if you are interested in our study material or logged and collected study data. And with that, I thank you for listening.